ወርቅ ዘመድ የለኝ ሀብት የለኝም ከእጄ ስማኝ ልጄ ሌት ፀሐይ ነው ላልተማረ ሰው ግን ቀኑም ጨለማ ነው ተማር ልጄ ወርቅ ዘመድ የለኝ ሀብት የለኝም ከእጄ ስማኝ ልጄ ሌት ፀሐይ ነው ላልተማረ ሰው ግን ቀኑም ጨለማ ነው
Well, welcome to this audio video tutorial, and I am invited here to Mr. Almayo Shetty's music. It's called Tamar Lije. Because education is the base of for our life. I think now we are in chapter 3, which says that the function. So in this chapter, we will try to see some concepts of functions, and the outlines are these are the outlines. The revision about relation and function. We'll see operation of a function, and we'll see type of function, and at the end we'll see some kind of important function. Let us see the learning outcome. By the way, after the end of this video learning, students are able to understand the difference between relation and function, determine the domain and the range of a relation and function. You will able to operate function. You will able to find the inverse of a relation. You will be list type of function, and also you will able to define different kind of function such as polynomial, exponential, logarithm, and trig function. Topic 1 says that relation. First, let us define what relation. By the way, relation is what set order pairs like this. For example, this relation is 2, 3 minus 5, 4, 2. This how many elements? This relation, the 1, 2, 3, 4, 5. This is a relation. By the domain is, I think you know, it is not. I think you are familiar for this. So the domain is 2 minus 1, 4, 9, 0. In order to put their ascending order, it's better. But you can say 2 minus 1, 4, 9, 0. You know, the domain means the x value, and the range is 3, 5, minus 2, 9, and minus 6. These are the range. Is the set of all value of y in the relation. And the relation. These are the domains. And for example, we can express a relation in such like this. 1 is related with 6, 2 is this, and we can create a relation. Now the domain is set of all x, and the range is the set of all y. This relation can be written in listing method. We can write like this. So what is function? By the way, function is a special type of relation which domain is not repeated more than one time, or a function from a set A to set B is a rule correspondence that assigned to each element x in the set A exactly one element y in the set B. Now let us see these two sets. Must use all x's to say a relation. They must be, we have to use all x's. Look this. Now the relation is like this. Now oral assigned. The first criteria to be say a relation is, I mean a function is oral assigned. No x has more than one assigned. Now 1 is only assigned 4, 2 is assigned only 2, 3 is related only 10. So this is we can say this is a function. For example, let us say this is not a function. Look this relation. Is this a relation? I think it is not. Because why? 2 is assigned or relate with what? With 4 and with 10. So the domain is repeated more than one time. So this is not a relation. 2 was assigned both 4 and 10. The reason is that. The reason is that. So this is not a relation. By the way, I have a classwork. Which one of the following is a function? R. xy says that x is a father of y and this b is type error. Please correct my student. R is equal to xy says that y is a father of x. So I'll give you 2 minutes. The time is up. Okay, which one is a relation? By the way, first you have to understand what does this mean. For axy is such that x is a father. So the domain is father and y are children. Of what? X is a father of y. Okay, means x is a father and y is a children. Okay. B, y is a father. So in order to make clear, let me take my families. Take my family. By the way, I have 2 brothers and 2 sisters. For example, for A, the relation is like this. My father is Tashagar. Therefore, it says that, remember, X is father of Y. X is a father of Y. So in place of X, we will repeat our fathers. My sisters and my brothers, including me, fathers. So in place of X, Tashagar, Tashagar, Tashagar. Okay, here is me, Matuku, and Andavat is Magdas, my sister. So this is a relation, by the way. Now, is this function? No, it is not function because the domain is repeated more than one time. More than one time. One time. For B, the relation is like this. B says, I think, B says, Y is a father of X. So X are children. So Mitiku and David Magdas. Is this a relation? Of course, it's a set of order pair father or children. Okay. Is this a function? Okay. What does it mean? When I ask you, is this a function? It means that does Mitiku will have another father without Tashaga? Think over it, my student. I will repeat it. When I ask you, is it a function mean? Does Mituku have another father without one father, which you call it Tashaga, Mr. Tashaga? It's impossible. I think you also have only one father. So such kind of relation is called function. That is why function is a special type of relation, which domain is not repeated more than one time. I think now you are clear the difference between relation and functions. If you are clear for the functions, how we operate. By the way, we can add, subtract, and we can make a product, and we can divide a function. So if you have 2 functions, we define the following 4 functions. This is the sum of 2 functions. This is the difference of 2 functions. This is the product, and this is the quotient. Bear in mind, don't forget g of x must different from 0. Since x value must be an input into both f and g, the domain of f plus gx is the set of all x common to the domain of f and g. This is usually written as the domain of f plus g is the domain of f intersection with the domain of g. Similar statement holds true for the domain of the difference and the product of two functions, but in case of division, in case of the quotient, we must impose the additional restriction. I think you know that the denominator must be different from zero, additional restriction. So for example, let us see this example. Let f of x equal to x plus 8, g of x equal to x minus 2. Let us find f plus g and f minus 2. So f plus g is equal to f of x. Simply, it's simply a matter of addition. It is very, by the way, it's trivial. It's trivial, and the minus 1 is like this, but don't forget this minus. Most students make an error. This minus is posed for 2x minus 12. Then lastly, we get a functions like that. Okay, let us multiply this. So this x squared times x, a cubic, like this, we will get like that. So it's usual multiplication, by the way. It is usual, but no new things here. No new thing is here. Now, when you divide this, x squared minus 1, what is the domain of this? All real number, all complex numbers, or complex number, because real number are a subset of, but the usual one is a real number. X squared minus 1, the domain is all real number, also the set of all real number. Now, let me ask you, is the domain of f over g is all real number? Because a real number intersection real number is a real number, of course. So can I say that? That is why in the above slide we have to impose or put one additional restriction, which is g of x different from 0. So g of x is x plus 1. So this is another point. So the domain must be different from all real number. What is the domain? All real number without 1. By the way, don't forget, f over g is always equal to x minus 1. It is false for all real number. It is true when for all real number without 1. So without 1. And I think you heard the word for golf. Such things are called a composition of functions. Let us define, given to function f of x and g of x, the composition of the two functions do not by like this. We call it fog or golf. It is defined like this. Fog of x is equal to f in bracket, g of x in last closed bracket. So this is called composition of function. To visualize or to the best understanding to you have, let us see this example. For example, now the order of function operation is the same as the order of operation for the number and expressions. For example, find fog of 3. First you have to evaluate what is g of 3. G of 3 is 6. So then f of 6 is what? 12. So this is called a composition of the function. For example, let's evaluate the composite function of this. G of x is to the power of x. G of x is 7 minus 6. Then find fog of 4. Step 1. First, what is G of 4? Means substitute 4 from here. We get 3. So f of 3 will be the property of f, considered as a machine. When you give an input, it will be like to the power of the input. So give 3 to the power of 3 is equal to 8. So fog of 4 is what? 8. Fog of 4 is 8. And the next one is type of function. There are three types of functions: one-to-one or injective function, on function, subjective function, and one-to-one correspondence or bijective functions. These are the three mainly type of functions. First, let us define what does it mean one-to-one function. A function is one-to-one if each element in the codomain has a unique pre-image. Or a function f from a to b is called one-to-one if whenever f of a is equal to f of b, then a is equal to b. No element b is the image of more than one element in a. In a one-to-one function given any y, there is always only one x that can be paired with the given y. A function is said to be injective if it is one-to-one. Don't worry, I will give you an example. For example, this is a one-to-one function. Why? No, every uppercase number has exactly one lowercase partner. Look, not every uppercase number has exactly one lowercase partner. A, capital A, small a. When you see this, now I think you will clear for here. This is one-to-one function, but this is not one-to-one function. Why? Because now look, a is related with 1, a is related with 2. Also, another domain is related with the same to a range. That means A and O have the same range. At this time, the function is not one-to-one function. Example. These are not one-to-one function. Why? For example, under the real number here, take -1. -1, if x is -1, what is y? 1. So, can you find the range y when you give some value of x? Yes. In other words, -1, when we input here -1, we'll get 1. Also, when we give 1 for this x, also we'll get what? 1. So we'll get such type of relation, -1, 1 and 1, 1. So such type of function is not one-to-one function. For example, let us see. Note that f of x equal to x squared is not one-to-one. If is from the set of integer. Why? For example, give -2, it will be 4. 2, it will be 4. Therefore, it is not what? One-to-one under the set of integer. But let us take a natural number. 1, 1, 2, 4, 3, 9, 5, 25, 10, 100. So, if you give 4, it will be 16. Can you get 16 rather than number 4? Of course, -4 will be due, but now we are restricted because the domain is a set of natural number. At the time, it will be one-to-one. So such things are one-to-one under the set of natural number, but it is not. Therefore, one-to-oneness is dependent on the given domain. The second type of function is onto. A function is onto if each element in the codomain is an image of some pre-image. A function f A maps to B is subjective or onto if the image of f equals its range. This equals explain, note the magnitude. A function f from A to B is called onto if for all B in B there is an A in such that f of A is equal to f of B. All elements in B are used. A function is said to be subjective if it is onto function. Let us see example. This is an onto function. This is not what? Onto function, because these 3 and 4 have no pre-image here. But 1 have pre-image, 2 have a pre-image, 3 have a pre-image, 4 have a pre-image. But 3 and 4 have no a pre-image. So this is not onto. For example, look this. Not onto. Under for example, 2x is from the set of natural number and 10 is not onto. Why? Give 1, you will get what? 1. When you give 1, you will get 2. When you give 2, it will be 4. When you give 3, it will be 6. Now the relation seems like 1, 2, 2, 4, 3, 6. But we know that 2, 4, 6, 8 are not the only element of natural number. There are 3, 5, they have no pre-image. So the function is not onto. But if the domain is even natural number, it will be onto. The others are like this. One-to-one and onto function. A function can both one-to-one and onto. A function is one-to-one correspondence, or a bijective, or reversible, or invertible, if and only if it is both one-to-one and onto. One-to-one and onto also called bijective or one-to-one correspondence functions. For example, this is one-to-one because no more domain here. A4 is only have one pre-image like this. This is one-to-one and onto, by the way. Is this onto? Yes. Onto, all have a pre-image and not repeated. This is neither one-to-one. Why? Because B and C are related to. It is not onto. Why? 4 have no what? Have no pre-image. So this is both one-to-one and onto function, or this is one-to-one correspondence function, or this is invertible in general. So the next point is inverse of the function. Given any function f, the inverse of the function is denoted by like this: f to the power of -1, but we read it f inverse. F inverse is the relation that formed by interchanging x and y of f, like this. So the function g would be denoted by as F inverse and read as F inverse, F inverse, F inverse. This is a machine. This is a machine. So the inverse of F is simply interchanging x and y's value. It's simply interchanging x, y. In graph, the inverse of y of x is this. So the inverse of a function is the original function with symmetry y is equal to x. Y is equal to x. A mirror image means mirror image. For example, when you look by a mirror, your right hand acts as left, I think, like that. So the inverse means like that. Like that. Example. Let y is equal to x over 5x minus 3. To find the inverses such as which x and x is equal to y over 5y minus 3. Then when you take some rearrangement, you'll get this. So the inverse is this. The inverse is 3x. After some steps, we'll get y is equal to 3x over 5x minus y. 5x minus y. So when you see the property of inverse function, only one-to-one function of inverse. Look, one-to-one function of inverse. If g is the inverse of f, then f is the inverse of g. We say f and g are inverse of each other. If f and g are inverses of each other, then both are one-to-one function. If f and g are inverse of each other, then the domain of f is equal to the range of g, and the range of f is equal to the domain of g. These are some property of inverse function. Here some activity 3.1. So in order to what you have more understanding and your to increase your skills to solve mathematical problems, please read and do it. If you have any questions, please send your question or comments by my email or by my Telegram channel. Thank you for watching this presentation. Next time we will see some important functions. For now, I thank you very much.